is a ratio of factors. And because this is 0, otherwise the chart will not work. I have to do some more work. Okay. This is the way. Okay. So x, 1 minus x, 2x plus 6, and 1 minus x over 2x plus 6. Which are the numbers for the top? 1 minus x equals 0 means x equals 1. For the bottom, 2x plus 6 equals 0, x equals negative 3. So I have to put them in the correct order. Negative 3 first, and 1 follows. Very good. Next step, I have to put the corresponding zeros. 0 in the first row for 1 minus x under 1, and 0 in the second row under negative 3. Now I need to put something here, right here, under negative 3 for the ratio, and under 1 for the ratio.
You can't be negative 3, so you have to block it out.
Awesome. Undefined. Very good. What about at 1? Excellent.
0.
Very good. Now the signs of 1 minus x. You either pick a number, or you remember that this looks like this because it's a negative slope. From positive, it crosses the x-axis and to negative. This one, positive linear, positive slope, so it's from negative to positive. The first subinterval negative, the second one positive, and the last one negative. Now I'm asking myself, what do I want? Which sign is greater than 0? Which sign do I pick? Yes, so I have to pick this interval, which means this interval. So x is between negative 3 and 1. I cannot pick negative 3 because it's undefined. I cannot pick 1 because I don't have the equal symbol here. So it's going to be parentheses on both sides. So x in the interval negative 3, 1.
I got the same numbers, but in a very different way.
How different?
I mean, I just did like that normal thing. I just changed the. I erased it all. I changed that to an equal sign, and then I just like cross multiplied.
Oh, absolutely not.
No,
Don't
it's
even-
same
don't even
number.
try.
Same number is wrong. It wouldn't have given me the correct way of doing it. It's just to go
What
back
is
to.
he saying? What is he saying?
I don't know what I'm saying.
Good. Okay. As long as you don't do that on the final, please. I'm begging you.
I'll try.
Okay. Good. Next question. Okay, very good. So which one would you like to look at? Okay. So f of x equals 2 times x minus 2 over x minus 2, x minus 1. I have to do that right away. I have to factor immediately. I have to find the domain, etc., etc., etc. So let's look at this function and identify what x cannot be first.
It cannot be positive 2 or positive 1.
Perfect. Only now I'm allowed to do this. So this is 2 over x minus 1. So then can anyone identify the domain now for this function? The domain is?
It's x minus 2 and then x minus 1. I'm sorry.
So if you look at the domain is x squared minus 3x plus 2. So I had to factor it already. So x minus 2, x minus 1.
Okay.
So what is the domain of this function then? So this is the simplified form. We're interested in the original function. I had to state two restrictions before I simplify. We are talking about this function. The domain of this function is everything except 1 and 2. Is that clear? Okay. So negative infinity, 0, 1, 2, infinity. You cannot identify the domain. That's why we identify the domain first, and then we simplify it. Okay, so what happens at x equals 1? And what happens at x equals 2? So obviously there are two different things. One factor disappears and another one stays. So they cannot be the same. So what happens when the factor disappears?
There's a hole.
Excellent. What happens when the factor stays? Very good, awesome. Indeed.
I guess.
You didn't. You remember. So what type of rational function is this? 1, 2, or 3? Should I repeat those three types?
Yes.
Perfect. So type 1, same degree over same degree.
Yes.
The horizontal asymptote is leading coefficient over the leading coefficient. Okay? Type 2, higher degree in the denominator than the numerator. Bigger, stronger in the denominator. Type 2, horizontal asymptote is always 0. Type 3, higher degree at the top by 1 unit higher. So if the top is degree 2 and the bottom degree 3 and degree 2, the quotient is a line. This line. If the top is degree 4 and the bottom is degree 3, the quotient is a line. This line. No horizontal asymptote or asymptote.
So the same degree or same
Really? What is the degree of the top? No.
0.
No, there is no x.
So we're that way.
That's type 3. When the numerator is higher,
That's 3, right?
yes, degree 3 over degree 2, or degree 4 over degree 3, or degree 2 over degree 1. That's not the case.
So we're type 2.
So it's type 2, because the degree of the top is 0, and the degree of the bottom is 1. So what is the horizontal asymptote?
0.
Exactly.
If I remember right, you said we would rarely see type 3.
Yes, because it has a slant asymptote, so I would not put a problem like that. We did not have it on the test. Yes, please.
When you're doing that, do you use the simplified form or
Exactly.
simplified?
Yes. Because once the factor goes away, but still it's the same thing. So the degree of the top is 1, the degree of the bottom is 2. So it's still type 2. Here now, the degree of the top is 0 and the degree of the bottom is 1. Still type 2, no matter what. So, but yes, I prefer to work now because I already established that this is a whole, that factor is gone now. And I prefer to work with a simplified form. Yes, very good question. So now, when I plug in 2 in the simplified form, because I cannot plug in 2 here, I will get 0 over 0. So now I can plug in 2 in the simplified form. What do I get on this side as well as this side? The same thing. What do I get? It has to be a number. If it's a whole, it has to be a number, not infinity. So 2 over 2 minus 1 is 2 indeed. Very good. Now this one, because it's a VA, yes. Now here I have to establish the sign with 0.9 and 1.1. So let's plug in 0.9 and just give me the sign. Very good. Please plug in 1.1 and just give me the sign. Yes. Never assume that if one is negative, the other one will be positive. It may or may not. Okay. So let's plug in 0 now and give me the y-intercept. Very good. That's all we need. So let's graph. When we graph a function with asymptotes, what do I have to graph first? Yes. So this is an overkill. Y equals 0 because it's the x-axis. But x equals 1 is very clear. It has to be there. And now I will plot the points I have. I have 0, -2, which is the y-intercept. And I have 2, 2, 2, 2 as a whole. That's all I really have. And now let's look to the left-hand side of the vertical asymptote. From approaching 0, crossing the y-axis, going towards -infinity. From approaching 0, crossing the y-axis, -infinity. From positive infinity, going through the hole, and approaching 0. So this is the function f of x equals 2x minus 4 over x squared minus 3x plus 2. Any questions on this?
Oh, Christmas.
You will remember when you review it. I have no doubt. Ready? Questions? So g of x equals -x, x minus 3 squared, x plus 2 cubed. What type of function is this?
You know it, say it.
Say it again.
Quadratic.
If the degree is 2, I'll say yes. If the degree is not 2, I cannot say yes.
Exponential.
It's not exponential because the variable is not the exponent. It's not linear because the degree is not 1.
Then we should throw it away.
No.
Polynomial.
Polynomial. Very good. It's a polynomial function. Degree, please.
3.
No, 5.
6.
Very good. 3 here, 2 here, 1 here. 3 plus 2 plus 1 is 6. Good. Maximum possible number of turns. Very good. It doesn't have to turn 5 times, but it cannot turn more than 5 times. Domain for every polynomial. Yes, friendly. Friendly. Very good. Okay, so when I solve g of x equals 0, how many solutions I get? And you have to say 6.
6.
Thank you. So please give me those 6 solutions. I'm ready.
3 or -2, 2 is 3, and 1 is just 0.
So x equals 0 indeed. Multiplicity 1. Perfect. X equals 3. Multiplicity 2. And x equals -2. Multiplicity
3.
is 3 plus 2 plus 1, 6?
Yeah.
Okay, so we identified everything correctly. Perfect. So let's get our table. G of x, -infinity to infinity, -2, 0, and 3. Of course. Please tell me what happens at -2, since multiplicity is 3. Yes, but how is it a straight cross or a slow cross? Very good. Thank you. At 0, 0, what happens at 0, 0?
Turn across.
Yes, just the regular cross, multiplicity 1. Finally, what happens at 3? Yes, it does turn. Very good. I need the end behavior and I'm done. Since the degree, one more time, is
6.
good, I can only compare it to 2 very simple functions. To the linear function or to the quadratic function. Only to one of them.
Quadratic.
Exactly, because it's even degree. I cannot compare it to a linear function because it's degree even, right? Degree 6 compared to x squared. So what is the end behavior based on the leading coefficient? Is it this?
No, it's negative, it's down.
Exactly, awesome. So that's the end behavior. Perfect, that's all I need. I plot the points. Any questions? Go ahead. If you want me to go back. Yes.
Are they supposed to be on the same graph or separate?
No. We were supposed to choose one. You were not even supposed to do both.
Okay.
No, it takes too long. So I was asking my students in the spring just to choose one. If they wanted to graph the rational, they will graph the rational. If they wanted to graph the polynomial, they will choose. Okay, not both. Is that okay?
Yeah.
Perfect. But since we are doing everything, that's why. Okay. So I have -2. I have 0, 0, 1, 2, 3. So let's identify what happens here and then graph it. So the function is coming from -infinity, and it will cross, but slowly cross. And then it has to come to a maximum because it comes back to cross again at 0, 0. It has to come to a minimum because it has to turn and come back at this point and turn again. One more time. From -infinity, a slow cross. It has to come to a maximum because all of a sudden it crosses again at 0, 0. It has to come to a minimum because it has to turn at this point and come down to -infinity. So from -infinity, slowly cross, up to a maximum, crossing, minimum, turn at 3, and down to -infinity. So 1, 2, 3 turns, not more than 5. So yes, I will have to graph this with the graphing calculator because I need to determine this maximum, I need to determine this minimum. So it has a local max, a local min, a local max. I don't need this because I know it's 3, 0. But for the other two, I need to determine them. Ready?
Are you serious?
Very serious when it comes to math and some other things. Okay, so -x in parentheses, x minus 3 squared, and then in parentheses x plus 2 cubed. Okay, so I graph the function. I know that left and right, -5, 5 will do, but I have no idea how low and how high. That part I don't know. So I'm going to change the viewing window and say -5, 5. With a scale of 1, it's good. So normally by now I'm cheating here, as you see right here, this little thing. Okay, I need to go high, high. Okay, so, but you don't have that. So I'm going to say 200 for minimum and 200 for maximum. Oh yeah, of course, I have to insert minus. Insert minus. Okay, and with a scale of 50. I will see if this is a good graph or not. A good interval. Yeah,
Oh, Christmas.
that's good. So as expected, see the difference between this cross and this cross?
Yes.
Because here there are 3 solutions the same. Here just 1. So it has a maximum, as we expected, it has a minimum, and this is the term. So I'm going to determine the maximum between -2 and 0, and the minimum between 0 and 3. So second and calc, I want a maximum 4, and this is between -2 and 0, and enter. And I will put it on my table, on my graph, -6.2, -0.62, and comma 21.4. And I will repeat for that minimum between 0 and 3. So second and calc, I want minimum now. I'll do it again if we need to. So between left bound is 0 and right bound is 3. Second and calc, I messed up something. Okay. Be nice. Okay, I want the minimum, which is 3. The left bound is 0, and then 3, and then enter. Okay, so 1.62, 1.62, comma, negative 146.4. Is this okay? When do you want me to show it again?
Oh, I'm totally messed up with that.
Do you have the function in?
No, well, the Y.
Yes. So did you graph it? Do you want me to show the viewing window again?
Yeah.
Okay, here it is. It's not the best viewing window, but it does the job.
Okay, I did that.
Okay, and then go to graph. Just click on graph.
This is invalid. So I must have done something wrong.
Can I take a look?
Sure.
So let me look at the function first. Oh, you have plots. That's what the problem was.
I have plots.
Yeah. You have highlighted some other functions in there. That's all. Okay, so very good. I de-highlighted those plots, so now it graphed perfectly. So you have the same graph like I do.
I was plotting.
Yeah, you had something in statistics.
I had no idea.
Someone must have used it. So, and then we determine this maximum. Let's do one of them. Do you want to do the maximum or the minimum? If they are the same.
Didn't we do the max?
Yeah, we did both. Okay, let's do the minimum. Okay, so you go to second and calc. Calc is right here.
Yeah, yeah.
And you choose the minimum, 3. And now you enter 0, enter, 3, enter, and enter again. Did you get 1.618 and y negative 146.35?
Yes.
Excellent. Good. Moving on.
But you're not gonna be there to tell me to do that on my child.
But you can ask.
Oh, I can?
Yes.
Will you tell me?
Yes. Yeah, if it's something on the calculator that you're stuck on, I'll help. Everyone. So h of x equals 1 over the square root of 2x minus 1. Okay, so here we are asked to decompose this function. Let's decompose it. I want an inner and an outer.
What is inner? Is that 9?
Yes. So I want the inner, please.
1 over square root of 2x minus 2.
Yes, that's one option. 2x minus 1.
I mean, yeah.
Yes. So when I have this number, what function do I apply to this number? There is more than one correct answer. You could consider this as your inner. That's fine too. There is more than one correct answer here. So you can consider, if you consider the square root, then which function you apply to this?
1 over x.
Exactly. If you consider as 2x minus 1 the inner, which function will you apply to 2x minus 1, to this number?
1 over square root.
Exactly. So both answers are fine. Very good. Moving on. I have 244. Do you want to continue? Or you want to leave this for from Saturday?